Вітаю. Well, that's the way we say hello in Ukraine. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, here we are discussing permutations, and permutations, like I'm sure you people must have looked up in the early lectures, is the number of arrangements which are possible. So, arrangements becomes a synonym for permutations. Now, remember, children, whether we talk about a permutation or we talk about an arrangement, it is always order specific. That means order has significance. So, if you keep some object at the fourth place and keep another object at the sixth place and exchange their positions, they will be two different permutations or two different arrangements. For that matter, I'm sure you know that if we talk about the 10 different digits of the number system, then they are all distinct or they are all different. And if there is a number in which the position of the digits is exchanged, then it becomes a different number. Similarly, when we talk about permutation of n distinct objects, when say some r objects are taken at a time, then that becomes the notation of the permutation. And children, that is written something like this. That is, you have it to be n PR. Always remember here that n is larger than r, right? That is, the number n will have a natural number value, the number r will have another natural number value, and the value of n is going to be greater than r. Right? So here, children, when we talk about this notation is further written as a formula like factorial n divided by factorial of n minus r. Right? Now, children, let us have a live case with the help of which you will be able to understand more. For that matter, let us say now we have some 10p4 which requires to be calculated. Now, here, as you see, the value of n is 10 and the value of r is 4. And you must have also seen that the value of n is greater than r. And when we are to calculate this, then we can write this as factorial 10 divided by factorial of 10 minus 4, and that, children, will then become equal to factorial of 10 divided by factorial of 6. Right? Now, how do we calculate this further? We can write this as 10 into 9 into 8 into 7, and further multiply this with factorial 6, because factorial 6 obviously is going to be 6 into 5 into 4 into 3 into 2 into 1, and that is what is required to complete factorial 10. And now, as you have factorial 6 in the denominator, so both of these factorial 6's from the numerator and from the denominator gets cancelled, and then you are just left out with 10 into 9 into 8 into 7, right? So for the children, we will now multiply 9 into 8, which is 72, and further multiply it by 7. So 72 is to be multiplied with 7. 7 2s is 14, 1 remainder. 7 7s are 49, and 1 is 50. So that then becomes equal to 5040, as it is further to be multiplied by 10. So this is the number of permutation, or it is the number of arrangements which are possible. So I'll just quickly discuss this once more. In the question, children, here we've been given that we've got to calculate 10p4, that is, out of 10 distinct objects, we've been given 4 different objects are to be taken at a time, and then the permutations are to be formed. So this is calculated as factorial 10 divided by factorial of 10 minus 4, or n factorial divided by n minus r factorial. Now, for the children, we write this 10 factorial as 10 into 9 into 8 into 7 into factorial of the number which is there in the denominator, that is factorial 6. Because all of this, if you write, then this will be written as 6 into 5 into 4 into 3 into 2 into 1. That is the same as factorial 6. Factorial 6 gets cancelled from the numerator and from the denominator, and then you are just left out with 10 into 9 into 8 into 7, which can further be multiplied to get to the result, which will be the number of permutations or the number of arrangements which are possible. Is this clear with everybody? Sure? Good. Now, children, after this, I have a sum for you people, which I'd like you people to try for a little while, after which I'll be discussing the sum with you people. Right, children, now let's discuss the sum. Here in the question we've been given, find the number of signals that can be formed by arranging at least 3 flags in order on a vertical pole when flags of 6 colors are available. So if the flags are of 6 colors, then obviously they must be such that they all look to be distinct. Some can be of violet color, some can be of red color, or probably yellow, green, whatever, right? So all of these different flags can be put on a vertical pole and some signals are to be made out of it, right? So let's say now here, if we talk about these signals which are formed, they are to be formed such that the value of n here is how much? N is 6. And if you are to talk about r here is given to be 3, right? But remember, children, this is not the only case, as this is one of the cases when 3 flags are put at a time. At the other time, 4 flags will be taken, then 5 flags will be taken, then 6 flags will be taken, because here you've been given that at least 3 flags are to be taken, right? So if we talk about the case of at least 3, then at least 3 means that we'll be talking about 3 flags to the least. Then we can also talk about 4 flags, because 4 flags are also available. To that, then we add the case of 5 flags, and then further to this we also add 6 flags. Now when we talk about these cases, why is there a plus sign which has been used? Because these cases are not dependent on each other, or they are not related with each other. That means when we take 3 flags, it is nothing to do with when we take 4 flags, and when such is the case, we put up a plus sign, and this is contrary to the method of multiplication that we have, right? The method of multiplication is used only when there is some correspondence, or there is some relation which is possible among the cases. Here, as there is no relation among the cases, so that's why we put up a plus sign, because we require all of these cases, and as they are not related, we add them to get the total number of cases. Now when we talk about here 3 flags, then 3 flags, children, can be written as total number of flags being 6. The number of permutations are required, so 6p3. Then when we have 4 flags, then that will become equal to 6p4. For 5 flags it will become 6p5, and then for 6 flags it will become equal to 6p6. Now children, we apply the formula or the notation that we know, that is, when we talk about NPR, we have it to be equal to n factorial divided by n minus r factorial. Now writing this next, we will now have our final value to be equal to 6 factorial divided by 6 minus 3 factorial, to which is going to be added 6 factorial divided by 6 minus 4 factorial, and to that is to be added 6 factorial divided by 6 minus 5 factorial, and then lastly we have 6 factorial divided by 6 minus 6 factorial. To calculate this further, we can write this as 6 factorial, right, divided by 3 factorial, plus we now have next 6 factorial divided by 2 factorial. To that then is to be added 6 factorial divided by 6 minus 5, that is factorial 1, and lastly we have 6 factorial divided by 6 minus 6, that is 0 factorial. Now next children, after this, when we are to calculate this like we calculated earlier, this will become 6 into 5 into 4 into factorial 3, and in the denominator we have factorial 3. To that is to be added 6 into 5 into 4 into 3 into factorial 2 divided by factorial 2. To that is to be added 6 into 5 into 4 into 3 into 2, right, into factorial 1 divided by factorial 1, and lastly we will have this as factorial 0 is equal to 1, right, and thus here lastly we will have what we had earlier, that is factorial 6. right? Now children, we will find out the values of all of this. Here factorial 3 will get cancelled, and in the second term we will have factorial 2 which will get cancelled, and obviously as factorial 1 is 1 being multiplicative identity, so we can just forget it. So further, when we calculate this comes to 6 into 5, 30, 30 into 40 is 120, to which then we add 6 5s are 30, and then 4 3s is 12, so that becomes equal to 360. Now we will further have to multiply this with 2, so the next one becomes equal to 720, that is factorial 6, and the last is also factorial 6, which will become equal to 720. Right guys, so next now we have to add all of this, that is 720, 720, 360 and 120 are to be added. So now we have 0, 2 and 6 is 8, 8 and 2 is 10, 10 and 2 is 12, one remainder, 7 and 1 is 8, 8 and 7 is 15, 15 and 3 is 18, 18 and 1 is 19, so we have 1920, which becomes the number of signals which are possible when at least 3 flags are taken at a time. So now children, I'll just quickly discuss the sum all over. In the question you've been given here that we have to talk about the number of signals that can be formed by arranging at least 3 flags in order on a vertical pole when flags of 6 colors are available. So the total number of flags gives us the value of n, which is 6. Then as at least 3 are to be taken, so first we take 3, then we will be taking 1 more than 3, that is 4, then 1 more than 4, that is 5, and then 1 more than 5, that is 6, right? So thus we have 4 cases here when there are 3 flags, 4 flags, 5 flags and 6 flags. Now when we talk about 3 flags, then the number of permutation will be given by 6p3. When we have 4 flags, the number of permutations will be given by 6p4. When we have 5 flags, then the number of permutations will be given by 6p5, and when we have 6 flags, the number of permutations or the number of arrangements will be given by 6p6. Remember, we are to put up a plus sign between all of these different cases. That is because none of these cases has some connection or has some resemblance with the other, right? And that is the reason, because there is no correspondence which is possible among them, so we put up a plus sign, right? Whenever there is some relation or whenever there is some correspondence which is possible among the cases, we put up a multiplication sign as has been given to us by the principle of multiplication. Now for the children, after this what we do is we now call in NPR, which is the notation of permutation, and that is given by factorial n divided by factorial of n minus r. Next now children, what we do is we talk about writing the value of each of these, that is factorial 6 divided by factorial of 6 minus 3 plus factorial of 6 divided by factorial of 6 minus 4 plus factorial of 6 divided by factorial of 6 minus 5, and lastly we have factorial 6 divided by factorial of 6 minus 6. Then children, when we have factorial 6, we can obviously write it as 6 into 5 into 4, and as we have factorial 3 in the denominator, we can multiply this by factorial 3 and divide it by factorial 3, where both of these get cancelled, and then we just have the product of 6, 5 and 4, which gives us 120. Next, when we require to divide factorial 6 by factorial 2, we can write this as 6 into 5 into 4 into 3 multiplied by factorial 2 divided by factorial 2, where factorial 2 will get cancelled, and then you will get the product of all of these numbers to be 360. Further now children, we have factorial 6 divided by factorial 1. So now when we talk about the product of the numbers which are there in the numerator, that will be 6 into 5 into 4 into 3 into 2 into factorial 1 divided by factorial 1. As factorial 1 is the same as the multiplicative identity, so as such it won't bring any hindrance, and then when we multiply all of these numbers we get to 720, and in the last case we get factorial 6 divided by 0 factorial. Remember that 0 factorial is equal to 1, right? As such here we can write this as factorial 6, which again will become equal to 720. Now when we add up all of these, we get to 1920, which will then become the number of permutations or the number of arrangements which are possible when we talk about at least arranging 3 flags, such that the total number of flags which are available are 6. So have you all been able to understand this? For sure. That's good, guys. Now, make sure you study all of these lectures one by one and also practice these sums once in your copies, and then you can try out more sums from your books. I'm sure you'll be able to crack them. Bye, children. Have a nice time. Bye.